Hello everyone, in chapter 7 functions, limits and continuity, we'll do a quick revision about this very important chapter. In part 1 limits of a function at infinity, in part 2 limits at a point, part 3 operations of the limits. Limits at infinity, we say that limit of f of x as x tends to plus infinity equal plus infinity. In this case, when x goes much bigger to plus infinity, when x goes to plus infinity, increases in unlimited value, then the f of x, the function or the curve, goes also to plus infinity without limit. Okay. Limit f of x as x tends to plus infinity equal minus infinity. It means when x goes much bigger, okay, so the function or the curve decreases to minus infinity or increases in negative sense. It goes down without any limit, without any bound. It can't be stopped. It goes to plus infinity. Limit of x as x tends to minus infinity equal plus infinity. In this case, x goes much bigger in negative sense. The function or the curve goes upward in positive sense without bound. It goes to plus infinity. Limit f of x as x tends to minus infinity equal minus infinity. It means that when x goes much bigger in negative sense, goes left, okay, then the curve or the function goes down without any bound. Finite limits, it means the opposite of infinite limits is finite limits. It means that the limit is equal to a number. Okay, this L may be a number 1, 2, 3, 0, 500, any number. So in the case when x goes much bigger, okay, when x tends to plus infinity, goes to plus infinity, when x goes much bigger, as we see here, the curve is going down, down, and down until it reaches a number. It couldn't go below this number, which is in this case 3. Okay, so as x goes much bigger, the function goes down and very close to 3. So we say limit f of x at plus infinity equal 3. In this case, when x goes to minus infinity, the limit of f of x equal minus 4. When x goes to minus infinity, okay, the function closes to minus 4. So we write minus 4. Horizontal asymptote. When do we say horizontal asymptote? When limit f of x as x tends to infinity plus or minus infinity equal L number, then we say y equal L is a horizontal asymptote at plus infinity. As in this case, limit as f of x as x tends to plus infinity equal 3, it means that it's when x goes much bigger, the function goes very close to this number 3. It couldn't go below 3. Okay, so we say here that y equal 3, the line y equal 3, the straight line y equal 3 is a horizontal asymptote, okay, at plus infinity. In this case, when x goes to minus infinity, the limit of the function is equal to 5 at minus infinity. So we say y equal 5 is a horizontal asymptote at minus infinity. Limit at a point. When the limit of f of x as x tends to a, as x is very close to a, this is a, is plus infinity, as we can see here. When x very close to a, the function goes upward without any bound to plus infinity. Okay, this is called limit at a point. As in this example, as x goes very close to 1, limit f of x when x tends to 1 equal infinity. Okay, when x tends to minus 3 equal minus infinity, is going down without any bound. Limit f of x when x tends to 3 equal minus infinity is going down without any bound. Okay, and we should differ between 1 plus and 1 minus, or a positive, a plus, or a minus. In this case, when x goes to 1 plus, this is 1. 1 plus, it means that it is bigger than 1 a little bit, or x greater than 1. يعني x going to 1 but from right to left. Okay, that way. So we can see here that the function is going upward without any bound, so we write plus infinity, but here 1 plus. Limit as x tends to 1 minus. In this case it is 1 minus 1, but below 1. X is less than 1, or before 1 a little bit, so the function is going upward without bound to plus infinity, so we write plus infinity. In this case, as x tends to minus 2 minus 2, but minus before minus 2, the function is going down without any bound, so we write minus infinity. And limit as x tends to 2 plus is equal to minus infinity in that case. In this case, we say x equal minus 2, the straight line, this is straight line, x equal minus 2 is a vertical asymptote, and x equal 2 is a vertical asymptote. As in this case, when x tends to 3 minus, it is minus infinity. Also to 3 plus, it is minus infinity. Vertical asymptote, which is the case that we talked about here. In this case, x equal 3 is a vertical asymptote. In this case, x equal a is a vertical asymptote. The function goes very close to this number a. So we say when limit f of x as x tends to a number equal infinity, plus or minus infinity, it doesn't differ. It's infinity anyway. So x equal a is a vertical asymptote. As in this case, x equal 3 is a vertical asymptote. This line is the line of equation x equals 3. In this example, we can see that limit f of x as x tends to 0 plus as x tends to 0 plus equal plus infinity, it's going upward, and as x tends to 0 minus, and before 0, so it's minus infinity, is going down. Operations of limits, limit of f plus g equal limit f plus limit g, limit of f times g equal limits f times limit g, limit f over g equal limit of f over limit of g, whatever x tends to infinity or to 1 or to 2 or to any number, or to minus infinity or to 0 plus to 0 minus, the formula doesn't differ here. Those rules, you must memorize them well, very well. We wrote them before in your copybooks. You wrote them already. The indeterminate cases, you must memorize them very well. And also these rules, when a function times a function, so you must memorize them well. Non-zero number times infinity is infinity, infinity times infinity equal infinity, but the sign here, it depends on the signs of infinities here, so plus minus, plus plus gives plus, minus minus gives plus. Indeterminate case, when 0 times infinity, this is an indeterminate case. When f over g, number over infinity is 0, infinity over number is 0, and the sign of the infinity determined by the sign of the number and the sign of the infinity. Infinity over infinity is indeterminate. Number over 0 equal infinity. Also, the signs depend on the 0 plus or 0 minus, or the positive number or negative number, positive over negative, negative anyway. In this case here, we have indeterminate case, I think the last indeterminate case, which is 0 over 0 indeterminate. So these are the four indeterminates: plus infinity, minus infinity, 0 times infinity, infinity over infinity, 0 over 0. Those are the four cases when we have indeterminate cases. Hello, we'll study, we'll just make a quick revision about if we have infinity over infinity, 0 over 0, what should we do to the function? As in this case, when we write limit g of x as x tends to minus 3, if we substitute 3 up and down, we get 0 over 0 and determinate. So most of the cases, in most of the cases, we must do factorize. So if we factorize the numerator x cubed plus 27 by synthetic division we took before, so it will be x plus 3 into this x squared plus 9 minus 3x. So we simplify and we get this polynomial and we get 27. So we have a limit. Radical x of radical x minus 1 As x tends to plus infinity, we get infinity over infinity indeterminate. So we do factorize the denominator. We take radical x common. 1 minus 1 over radical x. We simplify radical x with radical x, and then we substitute infinity, or we can say that we substitute infinity. Limit 1 over radical x is 1 over infinity 0, so the answer is 1 over 1, which is 1. Limit at infinity of a polynomial, we take the highest power. Always we take the highest power, as we saw before in the examples. Limit of a fraction, when we have a fraction or rational function of polynomials at infinity, just at infinity, plus or minus infinity, we take the highest power over the highest power. So it will be limit 5x over x squared, for example, x squared over x squared over 5x. We take the highest power here and the highest power down, and that was everything.